Hello everyone, this is Sahil Kumar from University of Lucknow, BTech Civil final year student, and I'm going to deliver this presentation starting with table of content. First, introduction. Second, seismic retrofitting. Third, when is seismic retrofitting needed? Fourth, retrofit performance objectives. Fifth, need of retrofitting in existing earthquake vulnerable buildings. Sixth, problems faced by structural engineers. Seventh, basic concept of retrofitting. Eighth, some conventional approaches. Ninth, benefits of retrofitting. Tenth, case study. 11th, conclusion. 12th, references. Introduction. Earthquake creates great devastation in terms of life, money, and failures of structure. Earthquake mitigation is an important field of study from a long time now. Seismic retrofitting is a collection mitigation techniques for earthquake engineering. It is of utmost importance for historic monuments, areas prone to severe earthquake, and tall or expensive structures. Now, what is seismic retrofitting? It is the modification of existing structures to make them more resistant to seismic activity, ground motion, or soil failure due to earthquakes. The retrofit techniques are also applicable for other natural hazards such as tropical cyclones, tornadoes, and severe wind from thunderstorms. When is seismic retrofitting needed? The two circumstances are: first, earthquake damaged buildings; second, earthquake vulnerable buildings with no exposure to severe earthquake. Retrofit performance objectives. Public safety only. The goal is to protect human life, ensuring that the structure will not collapse upon its occupants or passerby, and that the structure can be safely exited. Under severe seismic condition, the structure may be total economic write-off, requiring tear down and replacement. Now, structure survivability. The goal is that the structure, while remaining safe for exit, may require extensive repair, but not replacement before it is generally useful or considered safe for occupation. This is typically the lowest level of retrofit applied to bridges. Need of retrofitting in existing earthquake vulnerable buildings. Buildings have been designed according to seismic code, but the code has been upgraded in later years. Building designed to meet the modern seismic code, but deficiencies exist in the design and or construction. Essential buildings must be strengthened like hospital, historical monuments, and architectural buildings. Important buildings whose services are assumed to be essential just after an earthquake like hospitals. Buildings the use of which has changed through the years, buildings that are expanded, renovated, or rebuilt. Problems faced by structural engineers are lack of standards for retrofitting methods. Effectiveness of each method varies a lot depending upon parameters like type of structures, material condition, amount of damage, etc. Basic concept of retrofitting. The aim is at CEB 1997. First is upgradation of lateral strength of the structure. Second is increase in the ductility of the structure. And the third is increase in the strength and ductility. Classification of retrofitting techniques. Retrofitting techniques are classified in two categories. The first one is global technique and the second one is local technique. The first one contains adding shear wall, adding infill wall, adding bracing, adding wing wall, wall thickening, mass reduction, base isolation, and mass dampers. And the second one contains jacketing of beam, jacketing of column, jacketing of beam and column, strengthening of individual footings. Some conventional approaches. Adding new shear walls, frequently used for retrofitting of non-ductile reinforced concrete frame buildings. The added elements can be either cast in place or precast concrete elements. New elements preferably be placed at the exterior of the buildings, not preferred in the interior of the structure to avoid interior moldings. Some conventional approaches, adding steel bracings, an effective solution when large openings are required. Potential advantage for the following reasons: higher strength and stiffness, opening for natural light. Amount of work is less since foundation cost may be minimized. Add much less weight to the existing structure. Here is the figure showing the effect of adding shear walls. Here is the RC building which is retrofitted by steel bracing. Some conventional approaches. Jacketing, which is local retrofitting technique. Most popular technique for strengthening of building columns. Type 1. Steel jacket. Second, reinforced concrete jacket. Third, fiber reinforced polymer composite jacket. Purpose for jacketing: to increase concrete confinement, to increase shear strength, to increase flexural strength. Now here is the figure which shows the purpose of column jacketing. Cracks repair by grouting. Grouting is a process of injecting mixture of cement, sand, water at high pressure in the cracks, joint, voids, etc. Purpose of grouting: to strengthen the porous concrete, to prevent the seepage in dam and water retaining structures, to reduce uplift pressure below dam, to fill the cracks in concrete structure. Here is the image of procedure of grouting. Benefits of retrofitting: saving on capital expenditure while benefit from new technologies, optimization of existing plant components, adaptation of the plant for new or changed products, increase in piece number and cycle time, guaranteed spare parts availability, reduced maintenance cost and increased reliability. Case study: project overview. Location: Mani Mandir at Morbi, Gujarat. Project restoration and retrofitting of Mani Mandir complex at Morbi, Gujarat. Details of Mani Mandir: total area of Wellington Secretariat is 4900 meters square on ground floor, 4150 meters square on first floor, 225 meters square a part of second floor. The Secretariat building has large central courtyard housing the Mani Mandir temple, built in the 1930s by the ruler of the Morbi. Here is the figure of Mani Mandir Morbi. Local deficiencies: inadequate shear capacity, existence of short and stiff columns, lack of tie reinforcement, frequent volume batching, additional water for workability, poor quality control. Local retrofit strategies: concrete jacketing, steel jacketing, addition of concrete, reduction of irregularities. Second case study. Project overview. Location: Rumi Gate at Lajpat Nagar, Lucknow, Uttar Pradesh. Project: restoration and retrofitting of Rumi Gate at Husainabad Road. Details of Rumi Gate. Properties of original material. Compressive strength of brick used in approximately lies between 15 MPa to 17 MPa. Modulus of elasticity was found to be 5.7 GPa. Water absorption is almost 11.4%. Porosity was calculated to be 19.9%. Properties of repair material. Contemporary brick compressive strength is approximately 20.8 MPa. Modulus of elasticity was determined to be close to 6.1 GPa. Water absorption is 12.4%. Problem encountered with material. The material which was used by ASI in the repairing of Rumi Darwaja in Lucknow was failed after some time of application. The material which was used in construction did not fit with the quality and basic property of original material, due to which whatever repair was applied was damaged again. The damage was even poorer as it was compared earlier. Avdi monument is made up of Lakhori bricks and lime crushed brick aggregate. Mortar ratio is approximately 1:2 or 1:3 by volume. The main reason behind the damage of repair work was variation in water absorption property. Conclusion. Seismic retrofitting is a suitable technology for protection of a variety of structures. It has matured in the recent years to a highly reliable technology, but the expertise needed is not available in the basic level. The main challenge is to achieve a desired performance level at a minimum cost, which can be achieved through a detailed nonlinear analysis. Optimization of techniques are needed to know the most efficient retrofit for a particular structure. Proper design codes are needed to be published as code of practice for professionals related to this field. Some references are provided here.